All right, let's get into it. Today we're going to break down a classic brain teaser that's all about logic, greed, and some pretty high-stakes negotiation. We've got 5 ruthless pirates, a chest packed with 100 gold coins, and a brutal set of rules where making one wrong move means you're taking a long walk off a short plank. So, I'm putting you in the captain's chair. You're Pirate A, the boss. You found the treasure, and now you have to convince your 4 crewmates to agree on how to split it. So, what's your offer? And remember, your very life depends on them saying yar. Okay, so here's the scene. We've got 5 pirates, and they're ranked by seniority. There's Pirate A, that's you, the captain. Then you've got B, C, D, and finally E. They've just stumbled upon a chest with 100 shiny gold coins. And now comes the hard part, deciding who gets what. Now we have to talk about the rules, the infamous pirate code. This is important. As captain, Pirate A makes a proposal for splitting the gold. Then everybody votes, including the captain himself. If the yars get a majority, or even if it's just a tie, the deal is on. But, and this is a big but, if the nays have a majority, the captain gets thrown overboard. Then Pirate B becomes the new captain and the whole process starts over. To solve this, you absolutely have to get inside their heads. Priority number 1, survive. That's always first. Priority number 2, get as much gold as you possibly can. And then there's this little wonderfully bloodthirsty detail. If a pirate's going to get the same amount of gold no matter how they vote, they'll always vote to toss the captain overboard, just for kicks. So here's the key to the whole puzzle. Every single one of these pirates is perfectly logical, perfectly greedy, and they all know this about each other. Now, your first instinct might be to just be fair, right? Maybe Pirate A should offer everyone an even 20 coins. Seems like a safe bet to guarantee survival. Well, in the cutthroat world of pirate logic, that kind of generosity would actually be a fatal mistake. The only way to crack this riddle is to do something that feels a little weird. You have to completely ignore the starting situation with 5 pirates. The secret is to work backwards from the simplest, most extreme outcome you can imagine. We have to figure out what happens if things go really, really badly and only a couple of pirates are left. So, let's imagine total chaos. Pirates A, B, and C have all walked the plank. It's now just down to Pirate D and Pirate E. D is the captain. What does his proposal look like now? Pirate D is in charge, so he proposes keeping all 100 coins for himself and giving Pirate E a big fat 0. He votes yar for his own plan. E obviously votes nay, but that's a 1-to-1 vote. It's a tie. And remember the rules? A tie means the captain's deal passes, so D gets everything, and E is left with absolutely nothing. For Pirate E, this is the worst possible outcome, and she knows it. Okay, let's rewind one step. Now Pirate C is the captain, and he's got D and E as his crew. How does he use what we just figured out to his advantage? Captain C is a clever guy. He knows that if his deal fails, it's D's turn, and poor Pirate E gets nothing at all. So what does C do? He proposes 99 coins for himself, nothing for D, and just one single solitary coin for E. Now, E is a perfect logician. She knows that one coin is infinitely better than the 0 she's guaranteed to get next. So she votes yar, C votes yar, and boom, the deal passes 2-to-1. You starting to see the pattern here? Each captain uses the threat of what happens next to get what they want. So with that in mind, let's rewind again. It's Pirate B's turn to make an offer to C, D, and E. What's his move? Captain B has already done all this math in his head. He knows that if he gets thrown overboard, Captain C takes over, and who gets 0 coins in that scenario? Pirate D. So B only needs to buy off D's vote. He proposes 99 for himself, 1 coin for D, and nothing for C or E. D knows 1 is better than 0, so he votes yar. B votes yar. That makes it a 2-2 tie. And guess what? The deal passes. And just like that, we're right back where we started. All 5 pirates are on the deck. Pirate A, that's you, has the floor. And because you've thought through every single one of these future possibilities, you know exactly what you need to do to not only survive, but to get incredibly rich. This isn't a guess. You can predict with 100% certainty who is desperate. If your plan fails, Pirate B becomes the captain. And in Pirate B's winning deal, who gets left out in the cold with nothing? Pirates C and E. They are your targets. So what does our brilliant, ruthless captain propose to keep for himself? It sounds insane, but the logic is ironclad. He proposes to keep a staggering 98 gold coins. So here's the final incredible deal.
Pirate A gives himself 98 coins. He gives nothing to B, nothing to D, but he offers just 1 coin to Pirate C and 1 coin to Pirate E. Why on earth would they accept that? Because they know if they vote nay, B takes over and they get 0. 1 coin is better than no coins. So they grit their teeth and vote yar.
So the votes are cast. A, C, and E all vote yar. B and D, furious, vote nay. That's a 3-2 majority. The proposal passes. Pirate A not only survives, but walks away with almost the entire treasure, all because of cold, hard, ruthless logic. This riddle is so much more than just a fun little puzzle. It's actually a fantastic, bite-sized introduction to some really powerful ideas in what's known as game theory, which is basically the science of strategic thinking. The entire solution hinges on an idea called common knowledge. It's not just that every pirate is a logician, it's that Pirate A knows that Pirate C is a logician, and Pirate A knows that Pirate C knows that Pirate D is a logician, and so on, all the way down. This shared web of knowledge is what lets them predict each other's moves with absolute certainty. The final outcome is a perfect example of something called a Nash equilibrium. Basically, it means we're in a situation where no single pirate can do better for themselves by changing their vote. Think about it from Pirate C's perspective. He's getting 1 coin. Could he do better by switching his vote to nay? No way. The deal would fail and he'd get 0 from Pirate B later. He's strategically locked in. So the math is perfect, the logic is unbreakable, but the result, 1 pirate walking away with 98% of the treasure, it feels completely absurd. It kind of leaves us with one last big question. If all the pirates are acting perfectly rationally, but the outcome is this skewed, maybe the problem isn't the players. Maybe the real problem is the game itself, and that crazy pirate code.